Hello everyone. On this video we will look at finding the least common denominator. Okay, so you may have a method that works best for you. By all means use that method if you have one, but if you don't, this is a process that works pretty well until you kind of develop your own process. Okay, so first you want to use a preferred method to factor your denominator, like the factor tree. Okay. Second, you want to rewrite the fraction with the factor denominator that you got from step one. Okay. Third, let me move this up a little bit. You want to multiply all of your numerators and denominators of each of your fractions until the fractions denominators all match. And I'll show you how to do that in the examples. Okay. Now, fourth, if you're adding or subtracting your fractions, you want to multiply all the terms together, then you want to add and subtract, and then simplify if needed. All right, so if you're still writing these steps, by all means, feel free to press pause, but we're going to go ahead and jump right into a few examples. All right, so let's say, for example, you want to find the least common denominator. We'll just have that as LCD of 1 over 8 and 5 over 12. Alright, so remember your first step. You want to factor your denominators. And I will use the factor tree. You can factor however you like. So our denominators are 8 and 12. So we're going to factor both of those. And I'll show you two methods to factor. One is where you factor all the way down to the prime number, so prime factorization. And then the other method is just partially factoring. So I'll show you both. Okay, so we have 8. Remember, 8 is 4 times 2. The 2 you can't factor anymore, so you can circle that. And the 4 is 2 times 2. And neither one of those 2's can be factored anymore, so you go ahead and circle it. Okay, so we know that 8 is equal to 2 times 2 times 2. All right, so now we factor 12, which is 3 times 4. Or you could use 2 times 6, whichever one. You'll still get the same answer. The 3 can't be factored anymore, but that 4 becomes 2 times 2. And neither one of those can be factored anymore, so we go ahead and circle those. So that means that 12 is equal to 2 times 2 times 3. Okay, so our second step, remember we rewrite our two fractions, but we replace the denominators with the factored versions of them. Okay, so you have 1 over 8, and you have 5 over 12. Okay, so we know 8 is 2 times 2 times 2. So that would make this 1 over 2 times 2 times 2. And 5 over 12 will become 5 over 2 times 2 times 3. Okay, so now we match up our denominators. How do we do that? Well, we look and see what's on both sides. Okay, so we have a 2 here, and we have a 2 here. Okay, so those match. We have a 2 here, and we have a 2 here. So those match. You have a 2 here, but you don't have a third 2 over here. So we need a third 2 over here. Okay, so this 2 and this 3, because you don't have a 3 over here, and we don't have a third 2 over here. Okay, so we have 1 over 2 times 2 times 2, and 5 over 2 times 2 times 3. I'm just rewriting what we have here. All right, so you get this 3. Since there's no 3 over here, you multiply this one by 3 over 3. So you have times, you can just write it in parentheses if you like, 3 over 3. All right, and since you don't have a third 2 on this side, you multiply this one, and I'll just move this right over here, by 2 over 2 to match this one. So times 2 over 2. So if you look at it this way, our denominator is 2 times 2 times 2 times 3, and this one is 2 times 2 times 2 times 3. So now our denominators match. So now we just go ahead and multiply it across. So we have 3 times 1, which is 3, over 2 times 2, which is 4. 4 times 2 is 8. 8 times 3 is 24. Then you have 5 times 2, which is 10, over 2 times 2, which is 4, times 3, which is 12. 12 times 2 is 24. So in this case, your least common denominator is 24. Okay, so this also teaches you how to get equivalent fractions. All right, so just a note that (1 over 8) and 3 over 24 are equivalent fractions. And 5 over 12, let me move that up, and 10 over 24 are equivalent fractions. Okay, how can you tell? Because if you simplify 3 over 24, you'll get 1/8. And if you simplify 10 over 24, you'll get 5/12. So they're equivalent fractions. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to a few more examples. All right, so let's say, for example, what if we wanted to find the least common denominator of 5 over 12 and 8 over 45. All right, so what I want you to do is go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify your answers. So if we go ahead and solve this one. First, remember you have to find the least common denominator. So we factor our denominator using the factor tree. That's one method, or any method that you like. So we know that 12 is 4 times 3. And that 3 can't be simplified, but that 4 can be factored to 2 times 2. So we know that 12 is equal to 2 times 2 times 3, just like it was in the last example. And this did not, well, that's first denominator. The second denominator, you have 45. Remember, that's 9 times 5. The 5 cannot be simplified anymore, but that 9 become 3 times 3. And neither one of those 3's can be factored anymore, so we go ahead and circle those. So we know that 45 is equal to 3 times 3 times 5. All right, so we go on to our second step. Remember, our second step is to rewrite our fractions with the factored out denominators. So we have 5 over 12, and I'll give it a little space, and 8 over 45. Remember, 5 over 12 just becomes 5 over 2 times 2 times 3. And 8 over 45 will become 8 over 3 times 3 times 5. All right, so now we go ahead and we match up our denominators. Okay, so you have a 3 over here and a 3 over there, so we don't have to touch that one. We have a 2 over here, but we don't have a 2 over here. Okay, so we underline that because we still have to work with that one. We have a 2 over here, but we don't have a 2 over here, so we have to underline that one. Okay, now for this one, we have a 3 over here, a second 3, but we don't have a second 3 over here. So we go ahead and underline that one. We have a 5 over here, but we don't have a 5 over here. So we go ahead and underline that one. Okay, so what does this tell us? Well, that tells us that this 3 and this 5 has to be multiplied over here, and this 2 and this 2 both have to be multiplied over here. Okay, so your two underlined values are multiplied to the other fraction. Okay, so I'm just going to rewrite it. 5 over 2 times 2 times 3. Give it a little space. 8 over 3 times 3 times 5. And we underline, underline, circle, circle, underline, underline. Okay, just the same thing we had up here. I just rewrote it. Okay, so since you have a 2 here and a 2 here, if you wanted to, you can make this 2 over 2 times 2 over 2, or you can make it just 4 over 4. Either way, it doesn't matter. But I'm going to make this 2 over 2, and then multiply it again by 2 over 2. Now with this one, that means on this side, let me move this arrow over a little. Since these two are underlined, I'm going to multiply this one by 3 over 3, and multiply this one by 5 over 5. Okay. Now if you look at all of our denominators, they should all have the same values being multiplied, although they may be in a different order. You have 2, 2, 3, 3, 5, 2, 2, 3, 3, 5. So we have the same denominators. So we can just go ahead and multiply our numerators and denominators and find our least common denominator. Okay, so 5 times 3 is 15. 15 times 5 is 75. Over 2 times 2 times 3 times 3 times 5, that actually becomes 180. And you have 8 times 2, which is 16. 16 times 2 is 32. Over, this is 180 also. So that lets us know that our least common denominator is 180. All right. And just like before, we know that (5 over 12) and 75 over 180 are equivalent fractions. Let me clean that. And we also know that 8 over 45 and 32 over 180 are equivalent fractions. Okay, so if you simplify 32 over 180, you'll get 8 over 45. And if you simplify 75 over 80, you'll get 5 over 12. Okay, so those are both equivalent fractions. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and do one more example. Actually, we'll do a few more, just to make sure. Okay, and of course, I want you to do this one on your own. Okay, so we want to find the least common denominator for 5 over 21, 1 over 7, and 3 over 14. All right, so go ahead and press pause and try to solve this one on your own. Use the same steps as the previous examples. All right, so I'm assuming you've pressed pause and you've already solved it. So let's go ahead and verify your answer. Okay, so remember your first step. You want to factor your denominators. Okay, so really with these, because they're pretty basic ones, you don't really need the factor tree. We know that 21 is 3 times 7. Okay, neither one of those simplify any more than that. 7 is just 1 times 7. And 14 is 2 times 7. Okay, so we really didn't need the factor tree for those. Okay, now we go to the second step. So this was our first step, just factoring our denominators. Then our second step, we rewrite our fractions. So 5 over 21, 1 over 7, and 3 over 14, we're going to rewrite those with our factor denominators. Okay, so we have 5 over 3 times 7. We have 1 over 1 times 7. And we have 3 over 2 times 7. All right, so what's the one thing we look for? We look for something that matches in all of the denominators. So we see we have a 7 here, a 7 here, and a 7 here. Okay, so you don't have a 3 in all of them. That 1, you don't really have to put it there, but we'll do it anyway. And you don't have a 2 in all 3 of them. So we'll see that this 2 will have to be multiplied to the other 2 fractions. And this 3 will have to be multiplied to the other 2 fractions. The 1 we can multiply to the other 2 if you want to. But when it's a 1, you don't really have to do it. But I'm going to do it anyway just to stay consistent. Okay, so I'm just going to rewrite these. So you have 5 over 3 times 7. And give it a little space. 1 over 1 times 7. Give it a little space. And 3 over 2 times 7. And remember, the 7s were circled because those appear in all of them. The 3, the 1, and the 2. So remember, this 3, that means you have to multiply it to both of those, the other fractions. So this one gets 3 over 3, and this one gets 3 over 3. All right, so the 1, and again, if you want to do the 1, you can. If not, you don't have to, because you go ahead and get that. You want a 1 in all of them, you can multiply this one by 1 over 1. And this one by 1 over 1. And again, you don't have to put the 1 if you don't want to. All right, now the 2 here, you want to multiply the 2 to those other 2 fractions. So this 2 gets multiplied to that fraction and that fraction. Doesn't matter which side. So you get 2 over 2. And we make a little more room. And 2 over 2. All right, so I'm going to go ahead and erase all of these arrows just to avoid some of the confusion. All right, there we go. Okay, so now let's look at all of our denominators, and we should have all the same factors on each denominator. We have 1732, 1732, 1732. Okay, so even they're in different orders, they all have 1, 7, 3, and 2 in the denominator, so you should be good. Now we just multiply them across. Okay, so we have 2 times 5, which is 10. 10 times 1 is just 10. So we have 10 over. We have 3 times 7, which is 21. 21 times, that's why you don't need the 1, because 21 times 1 is just 21. And 21 times 2 is 42. Okay, so 2 times 1 times 3 is just 6. So we have 6 over 42 when you multiply the denominator. And you have 3 times 3 times 1 is 9. So you have 9 over 42. So we see here that the least common denominator is 42. All right, so just like before, we're going to point out our equivalent fractions. Okay, so 5 over 21 and 10 over 42 are equivalent fractions. And then you have 1 over 7 and 6 over 42 are equivalent fractions. And last but not least, you have 3 over 14. Let me move this up a little. And 9 over 42 are equivalent fractions. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to one more example. Okay, so what if we wanted to find the least common denominator of 7 and 1 over 30? Excuse me. All right, so I want you to go ahead and press pause and try this one on your own. All right, so I'm assuming you press pause and you've worked this one out. So let's go ahead and verify your answer. Okay, now with this one, whenever you have a whole number and you're trying to find the least common denominator, you do not have to do the first 2 steps because you only have one denominator. So since your denominator is the only denominator, let me go ahead and clean that up a little bit. There we go. Since your only denominator is 30, then your least common denominator is 30. Okay, but I'll show you why that will be. Okay, so let's say if you have 7 and 1 over 30, kind of ignoring the first 2 steps, you make that 7 over 1 and 1 over 30. Okay, now you don't have to factor the denominator, because if you have 7 over 1, there's only one thing you can do to make that 1 match up with 30. And that is multiply 7 over 1 by 30 over 30. Okay, so whatever that opposite denominator is, that's what you multiply your whole number by. Okay, so 7 times 30 is 210. So you have 210 over 30. And you have 1 over 30. Okay, so when you have a whole number, it's actually fewer steps. So we know here that our least common denominator is 30. All right, so let's try one, and I want you to do it with a whole number just to make sure you have it. Okay, so find the least common denominator of 9 and 1 over 10. Okay, so go ahead and press pause and solve this one on your own. All right, so assuming once again that you've pressed pause and worked this one out, we already know just by looking at it that the least common denominator would equal 10. Okay, because there's only one denominator. Okay, why is that? Because 9 is just 9 over 1, and 1 over 10. So how do we get a 10 in this denominator? Well, we multiply it by 10 over 10. So 10 times 9 is 90 over 10. And this is 1 over 10, which gives us our least common denominator. But we saw that right from the beginning. All right, so hopefully this made sense, and I will see you on the next video.